Hello, welcome back to the Geography 300 video series for Geographical Data Analysis, WVU. The previous video stepped through quite a bit. It took us through what is the process of inferential statistics, illustrating that with an example of what's called the t-test, which is looking at two variables at the same place, one of them being binary, yes or no, does a place have a mask mandate, does it not, compared to a continuous outcome or a continuous variable at that place, the whether or not, or what the COVID rate is. And we can then say, are COVID rates the same in places with a t-test, with a mask mandate, or are they different in places with a mask mandate from those without? We picked a t-test. The t-test is something that, if you, again, want to relate this back to another set of previous concepts, it would be whether or not our two data sets, in a sense, or two parts of the data set, those places with the mask mandate, those places without. As so much with inferential statistics, as I have said, right before the exam, we are making a process from our sample of inferring from the sample to the population. The t-test basically has two samples. It has one sample with a mask mandate and one sample without a mask mandate. What it's really doing under the hood is asking, could these two samples have come from the same population? So it's willing to acknowledge that there is some difference, but to say, could they have come from the same population? As we are making that inference, making that assumption, there are, or that assumption or inference that they come from the same population, or they don't. There are some general assumptions, general statistical things that it's assuming are true. Like, it works best if the data follow a normal distribution. Basically, the math that's hidden in what the computer does treats the data as if it were normal, and if it's not, then it might make a mistake. There are other assumptions that are made that are specifically within the realm of geography. This video and the next three will look in turn at four different ways that spatial data specifically can produce pitfalls in our interpretation, can, in a sense, produce trouble spots, to bring in the PACT terminology, can have trouble spots in what we are doing, what we're trying to accomplish here. The first of these goes by the acronym of MAUP. That acronym stands for the Modifiable Areal Unit Problem. Now, if we break this down, we can say, okay, what's the modifier? What does that mean? Well, the areal unit is what we're studying, a county. The fact that we can then modify those, well, what if we redrew the county boundaries? Even with the same individual level data, and this is a problem that can appear with any aggregated data. If we change the units of aggregation, we can change the outcome. This is most, in its clearest form, through gerrymandering. So here, and this is definitely an extreme example, but here I have what amounts to, if we think of this as our area, and purple voters are voters for one party, brown is voters for a different party. And yes, I intentionally did not use red and blue. You'll notice there's a very clear spatial pattern, and purple has a little bit more. If I split this into 3 areas, so this state, as it were, gets 3 representatives in Congress. If I do it this way, each of the 3 divisions, each of the 3 congressional districts has a purple representative. And I think I accidentally erased a purple dot there. Another approach I can do would do this vertically. So again, assuming each of those 3 is about the same, here are 2 purple and 1 brown. The same points, the same underlying data. I haven't changed anyone's vote. But now I have changed that representation in Congress just by modifying the areal units. I can even take this one step further. If I keep this one about the same, and then draw this way. Now, this has more brown than purple. This has more brown than purple, and this has more purple. Completely purple. Even though there are more purple dots, 2 regions would be represented by the members of that brown party. So again, by changing the areal units, I can have 3, 2, or 1 representative from that purple party, just by redrawing the boundaries. There is another aspect here. So we can redraw the boundaries. I can modify those borders. There's also a scale issue within the modifiable areal unit problem. Of if I change from 3 to 5 or 3 to 1, if I have more or fewer districts, as it were, that too can make the relationship look different. So the basic idea of the modifiable areal unit problem: change the boundaries, you can change the answer, even of changing the boundaries of aggregation for aggregated data using the same individuals. You can get different interpretations, different results out the other end. Okay, that's a problem. What do we do about it? In some ways, we are given the data we have. if you have a choice of aerial units, picking something that is related to your process, that is useful for your process. To go back to the COVID example, we actually do have pretty sensible units that we can pick, which, assuming the COVID rates are available at the municipal or county scale, we can look at the exact boundaries of the places that have the mandates. If those are counties, we collect data by county, and we can have a very clear demarcation. Counties with, counties without. If it's by cities, well, okay, you find cities, and you set the COVID rates there, and all the places that are either cities without mask mandates, and you go, or people in county areas, not part of any city, where the county has not imposed a mandate. And again, you can choose those aggregations based upon the places and the boundaries of what is affected by those policies. So now you have boundaries that are useful for and related to that process you are trying to study, and allowing that process to inform that choice of aggregation. If you have that as a possibility, great, make use of that information. If you don't have that choice, then you simply have to pay attention and recognize how the unit that you have could be wreaking havoc with your results, and acknowledge that, and use that in interpreting and understanding your results. So recognize them within this context, and try not to just mess with the boundaries too badly, like certain gerrymandered political districts. So this is the modifiable areal unit problem. Change the units, you change the results. As always, if you have questions, please feel free to ask, to reach out by Zoom or email, and I will see you at the next video with our next interpretation pitfall. Have a good one.